Hello everyone. So this is first chapter of business data analytics where we are going to look into the introduction to business data analytics. These are the outlines of what we are going to talk for the first lecture today. So as the introduction, we would like to see the definition of data analytics and we would like to see what is data. Alright, so data is everywhere and we are surrounded by it in our daily life. In the world of business, massive amount of data are being collected and stored every second. So for example, in the web data and e-commerce, every time you visit a website or make a purchase online, data is being recorded. Businesses collect information about your browsing patterns, search history, and purchase behavior to understand the customer preferences and enhance user experiences. Then, when we talk about the financial transaction, let us think about our financial activities, bank transaction, credit card purchases, and online payment. All these interactions generate valuable data that financial institutions use for security, fraud detection, and also personalized services. Online trading and purchasing, for example, from stock trading to buying products on platform like Amazon, Shopee, TikTok. These online transactions generate data on a massive scale. So these data helps businesses analyze market trends, understand consumer demands, and optimize their supply chain. For social network, social media platform like Facebook, Instagram, Twitter, and also TikTok are treasures trove of data. So these social media platforms gather information about the user interactions, posts, likes, shares, and also connection, which is used for targeted advertising, trend analysis, and also social sentiment studies. So as a conclusion, we have a lot of volumes and variety of data being collected for both opportunities and also challenges. So businesses can actually use or leverage this data to make smarter decisions, but they also need to manage it responsibly to ensure the data privacy and also security. The pandemic has actually accelerated the rise of robotic, if you know, and also it accelerated the rise of digitalization and the onset of Industry 5.0. Like Industry 4.0, 4.0, which focuses on the use of AI, big data, and Internet of Things. IR 5.0 embodies these three systems and incorporate greater human intelligence. A new commodity spawns a profitable, fast-growing industry, prompting antitrust regulators to step in to restrain those who control its flow. So a century ago, the resource in question was oil. Now, similar concerns are being raised by the giants that deal in data, the oil of the digital era. So, the economists define new terms as commodity. Data is a new oil, AI is the new electricity, and IoT is the new nervous system. When we talk about data as a new oil, many industry experts and popular business publications, including The Economist, have recently attested that data, not oil, is the most valuable resource in the world. Industry experts have coined the phrase data economy to describe the influence and prominence of big data in today's society. But then the concept behind data is new oil. Is that just like oil, raw data isn't valuable in and of itself, but rather the value created when it is gathered completely and accurately, connected to other relevant data, and done so in a timely manner. So when the data is properly refined, usable data quickly becomes a decision making tools or information allowing companies to react to market forces and be proactive and intentional in their decision making. When we say data is a new all, we need to look into how much data that we have. Back in 2019, before pandemic occurred, these are how much data that we have. We have, for example, here Google processes 20 petabyte data a day. Facebook has 60 terabyte of daily log and so on. Then pandemic 2020 upended everything from how we engage with each other to how we engage with brands and the digital world. At the same time, it transforms how we eat, how we work, and also how we entertain ourselves. We can see in the latest statistic by Domo here in 2023, data never sleeps and it shows no signs of slowing down. And one thing that actually get my interest in this one, in 1 minute here, you can see that Taylor Swift song 64.9k streams. So can you imagine how many revenues that can she made? Then we can see here the quality of data that we have. What is the scale of some type of data? Back in the 90s, we only have byte of data as a basic unit of measurement. So during my time, I still remember when we store things in floppy disks, and one floppy disk could possibly store one document. We have a piece of music with 5 MBs, then we have 2 hours of film with 1 gigabyte and so on. And the scale that we are familiar with are megabyte, gigabyte, and currently terabyte. But do you know that in reality, we have petabyte, we have exabyte, and we have zettabyte, and the biggest in 2013 was yottabyte with 1000 zettabyte, which is the storage capacity of NSA data center in 2013. So things, okay, generates or store data from megabyte 10 to the power of 6 of data to brontobyte 10 to the power of 27 recently, and gigabyte 10 to the power of 30. These measurements will be used to describe the tremendous amount of digital pool formed by the IoT platform. Cisco predicts about more than 50 billion devices connected to the internet by 2020 and 75 billion IoT devices by 2025. And this huge number of connected devices reveal a corresponding gigantic amount of traffic and digital data generated and transferred from connected cars to traffic lights, home security system. We also have connected toys and also smart speakers. And then B2C, B2B IoT market is due to reach 50 billion connected devices this year and 75 billions by 2025. And then as a matter of fact, 40% of IoT created data is stored, processed, analyzed, and acted upon close to the edge of network edges where cloud shortcomings to meet the IoT requirement manifest. When dealing with data analytics, these are the terms that we can see frequently: data, statistic, analysis, regressions, model, and so on. So actually, what is data? Data is a set of values of subject with respect to qualitative or quantitative variable. Data, information, or knowledge are often used interchangeably. However, data will become information when it is viewed in context or in post-analysis or being connected with another relevant data. What about big data? Big data is any data that is expensive to manage and hard to extract value from. As the technology progresses, More V's of big data were singled out to describe new challenges that were faced in this domain, giving us list of 5 V's, main V's. And the V's are defined as volume, focuses the size of data that reaches the level of megabyte, terabyte, petabyte, and so on that we have seen previously. Velocity shows the speed of data in and out. It refers to dynamic features of data and the frequency of data. Variety refers to different form of data types and sources, such as textual information, traffic data set, music, videos, and so on. Veracity refers to the extent of the data that can be trusted, given the reliability of its source. For example, when receiving data from sensors, some devices may be compromised. Values corresponds to potential insights that an organization can derive from processing big data, referring either to the potential value or extremely low density value, and so much more V's that we can see here. Depending on the market need, the V's actually evolve. Some researchers go a step further and include visualization, variability, and validity, or also volatility in the V's. And Data Science Central has defined 10 V's of data, with some V's differ from previous 9 V's, and some researchers even going as far as to include 17 V's to describe the nature of big data. When defining data analytics, we need to look into the type of data first. Generally, we have two types of data: structured data and unstructured data. In structured data, we have relational data, or in simple examples are tables and transaction. Data can be displayed in rows, column, and relational databases. In the structured data, we are going to have numbers, we are going to have dates and strings, but not limited to this, and many more depending on the domains. We can see that structured data require less storage and easier to manage and protect with legacy solution. Structured data is very different with unstructured data. For unstructured data, the examples are text data, semi-structured data, XML form, graph data, streaming data, and more. Unstructured data cannot be displayed in rows, columns, and relational database, and the format might be in images, audio, video, and more. And it is estimated about 80% of enterprise data, which then required more storage and more difficult to manage and protect with legacy solution. This is one example of structured data, relational data, whereby we have column and row here. This is the example of unstructured data in the form of text data, or specifically we can see here is the web data. These are another type of unstructured data, semi-structured data with XML format, and here is also the graph data. And this one is the streaming data, is another unstructured data, the most famous type of data now, where different type of data are streamed together in real time, going to have big data processing. So data is generated from multitude of sources, each contributing into different landscape of information we have today. In the healthcare sectors, advanced technologies like genomic sequencing and MRI provide details medical data. The rise of broadband has transformed online interaction, with 2 billion photos uploaded to Facebook and also YouTube and so on. Video surveillance system captured real-time information for security and operational efficiency, while global proliferation of mobile devices create torrent of data from text messages and apps usage. Smart devices, including those connected to the IoT, connect real-time information and so on.